All right. Hey, folks, welcome for our session today. As I said, please tell a friend to tell a friend. This is going to be a very nice session. We have Wambui, but I usually say Kafuri, right?
Yeah, Kaburi.
Yeah, Wambui Kaburi in the house today. She'll be taking us through the Pragmatic Programmer book, which is is a classic. So if you know someone who might benefit from this, please just send them a link. And we are live both on YouTube and LinkedIn. As we had asked before, we are looking to get to 1024 subscribers on YouTube. So please help us get there. We are at around 660. So if you haven't subscribed, please go ahead and subscribe. We'll really appreciate to get the word out there. So without much further ado, I would like to introduce Wambui Kaburi. She's a software engineer at Microsoft and a friend of mine. I think we've known each other for quite some time now.
Yep.
And I'm glad that she'll be taking us through this book. This is our series on book reviews. We have a number of series that we do. We have deep dives, we have dev stories. But I think also she will come back for dev stories, Wambui, I think, at some point.
Yeah.
But today we're going to do a book review. This is our third installment. There's a book we did called Software Craftsmanship. That was, I think, the first book. And then the second one was Clean Code. And now this one. So welcome. And I'd just like to pass over the mic to you and feel free to go on from there. Thanks.
Thank you. Thank you so much, Anthony. Thank you for having me. It's a pleasure to be here. I remember when you first asked me about it, I was a bit nervous, but I thought about the kind of content this book has and how good it would be to share this knowledge with others. And I'm very grateful for the platform. So as Nanda said, I'm Martha. I'm Martha at work, but my friends know me as Wambui. I'm a software engineer and I work with Microsoft ADC, so the Africa Development Center. I like to say I've been solving real world problems, not that I've been working. I've been solving real world problems since 2019. So it's been about 7 years now. And I've been privileged to work with different teams in multiple organizations. So this has given me a bit of sense on what I like about the tech space, what I don't like, what things that I'd love to change, things that I'd love to build. And above everything else, I'm a community enthusiast and a DEI advocate. That's diversity, equity, and inclusion. And I'm a give champion here at Microsoft. What that means is I organize campaigns for giving. So I think with that, we can go ahead and get started with this book. So this book is quite interesting, to say the least. It's the Pragmatic Programmer, and it's your journey to mastery. So it's a classic book, as Nanda has said, and it's on software development. Actually, the original idea was to write a short paper, but they ended up writing a book. And it contains the lessons that the authors, Andrew and David, learned while working with their clients. It has changed the perspectives and slightly or heavily influenced a number of developers, myself included. And that's mostly because it truly understands what it means to be a programmer. And this book was first published in 1999, and it predates the Agile Manifesto of 2002, where these two authors were part of the 14 people that wrote the Agile Manifesto. So they released the second edition for its 20th anniversary. That's in 2019. And the old edition is still good, and still has knowledge on software development history, but it's a bit outdated, which is why they felt that they needed to release the updated version, which is the 20th anniversary edition. So it has about 100 tips, and it has 10 chapters, and it's intended for programmers who want to be more effective and efficient. So this book applies to everyone. It applies to programmers who are just starting out. It applies to experienced programmers who want to figure out, okay, what more can I add onto this craft? And it centers on how to effectively use software to solve problems. So the authors have taken the tone of a friend. They speak to the reader like a fellow developer, and you're treated like a colleague who has the same problems as the authors. And I liked that about it, because technical books sometimes can be intimidating, and they use big words and big programming languages and difficult concepts. But this was actually a very easy read, and it was very enlightening. So I think I can go ahead to talk about a pragmatic programmer. So who is a pragmatic programmer? The two main questions answered by this book are who and how. So first is who. Who is a pragmatic programmer? So pragmatic programming stems from a philosophy of pragmatic thinking. And the word pragmatic comes from the Latin word pragmaticus, which means skilled in business. And that was derived from a Greek word meaning fit for use. So when I decided to look at the Cambridge Dictionary to try and understand this a bit more, and it defines pragmatic as an adjective. The adjective is defined as solving problems in a sensible way that suits the conditions that really exist now, rather than obeying fixed theories, ideas, or rules. I also looked at Merriam-Webster, and it adds that a person who is pragmatic is more concerned with the matters of fact than with what could or should be. So basically, pragmatic programming, based on that definition, it's an attitude or a style or a philosophy of approaching problems and their solutions. So now that we've defined pragmatic programming, who is a pragmatic programmer? This is someone who thinks beyond the immediate problem, placing it in its larger context and seeking out the bigger picture. Because after all, without the larger context, how can you be pragmatic? It's in the definition of the word. How can you make intelligent compromises and informed decisions? In this book, they define a pragmatic programmer as someone who is not wedded to any particular technology, but they have a broad enough background and experience base to allow you to choose good solutions in a particular situation. Their background stems from an understanding of the basic principles of computer science, and the experience comes from a wide range of practical projects. So you have the theory and you have the practice. That combined makes you a very strong programmer. So a pragmatic programmer is someone who adjusts their approach to suit the current circumstances and environment. They judge the relative importance of all the factors affecting a project, and then they use their experience to produce appropriate solutions. Then it just doesn't stop there. You do all that continuously as the work progresses. So you do the job and you do it well. So this book describes how to be a pragmatic programmer, which is what we are about to dive into. So I wanted to highlight this particular quote. It's from the foreword, and it made a lot of sense to me. The foreword was written by Saron, who is the founder and CEO of CodeNewbie. So he says, programming is a craft. At its simplest, it comes down to getting a computer to do what you want it to do, or what you want your user or what your user wants it to do. As a programmer, you are part listener, part advisor, part interpreter, and part dictator. You try to capture elusive requirements and find a way of expressing them so that a mere machine can do them justice. You try to document your work so that others can understand it, and you try to engineer your work so that others can build on it. What's more, you try to do all this against the relentless ticking of the project clock. You work small miracles every day. I think this quote resonated with me so deeply because it talks about the different roles that you have as a programmer, which is so true. You're a listener, you're listening to the requirements. You are an advisor, you're saying, no, this might not work, this works better. Interpreter, you have to convert those user requirements into business logic and then into code. Then you're a part dictator. You're the one who will say, listen, either the tests run or we are not merging this code. So there's the different roles that you take on. And then you're the one who has the power because you're the one who's telling a mere machine what to do. And then you have this work that you're working on. You're making sure that others are able to understand it, but at the same time, others are able to build on it. And all this with the constraints of time. So him talking about working small miracles every day is something that I think all of us can relate. So he also mentions in the foreword that as a relative newcomer to programming, you need to change your entire mindset. So he likens this to an analogy about being a newcomer in a town. So you're new, you need to figure out, okay, where am I going to be getting my coffee? Where am I going to be getting my groceries? Where am I going to get my hair done, my nails done? Who are my neighbors? Who can I rely on whenever there's troubles? Like you're starting from scratch. So that's what he likens programming to when you're a newcomer. You need to have a change in your habits, your behaviors, your expectations. And this process doesn't just happen just because you know how to code. It must be met with intention and deliberate practice. So I think that gives us a bit of sense of introduction of what this book is about. And then in the next step, I'm going to give you a bit of chapter summaries, just a brief description of what I feel was the focus of each of these chapters. And then we can go ahead and discuss the key takeaways. So in chapter 1, this is the pragmatic philosophy. It presents the author's philosophy regarding software development. They emphasize adaptability, continuous improvement, and having a proactive mindset. So they emphasize the importance of taking responsibility for your work, how to be able to learn from your mistakes, and to avoid assumptions. They stress that pragmatism means doing what works, yes, but also maintaining high standards of professionalism and creativity. So it's a very, very nice introduction into the book. And the second one is chapter 2, a pragmatic approach. So this chapter builds on the previous chapter by exploring the effective approaches to problem solving and programming. And it highlights things like critical thinking, risk management, and the importance of managing complexity by breaking down large problems into smaller, manageable parts. So they have techniques like tracer bullets and prototypes, which are introduced in this chapter, and they are more on iterating and refining solutions quickly while maintaining direction. Chapter 3 is the basic tools. It builds on the programmer as an artisan metaphor. So we all know artisans. We know carpenters. We know smiths. We know cobblers. We know welders. So all these are people who have a craft and they use tools to succeed in their day-to-day job. Yeah. So a good maker starts with a basic set of good quality tools. So this chapter focuses on the essential tools and practices that every programmer must master in order to excel in their world. So think of command shells, automation, version control, IDEs. These are the things that every programmer across the world will utilize. They will have them as their tools. And the authors here, they emphasize that you need to have a toolbox, your own personal toolbox where you're able to streamline workflows and improve productivity so that it encourages you as a developer to pick a tool that will enhance your craft. So a good example is, say, an IDE like Visual Studio Code. If you're able to use Visual Studio Code properly, it doesn't matter what language you're working in, yeah? Whether you're working on a project that uses C# or uses Java, you'd be able to switch between the two languages within the same IDE. So once you're able to understand your tools, anything that comes on is just a matter of translation and interpretation. Then in the next chapter, in chapter 4, we talk about pragmatic paranoia. So this chapter emphasizes defensive programming. So how do you prepare for unexpected issues? And when these unexpected issues come, how do you minimize their impact? So the key ideas here are like avoiding blind trust in inputs, handling failures gracefully, and being vigilant about edge cases. I feel like edge cases is something that we might leave out, but it's very important because those are the ones that really test the durability of our applications. The authors here, they stress that you need to be paranoid not only with others, but with your own self. And when you balance that with pragmatism, you make systems that are robust and are resilient in the face of any situation. Then in another chapter, we have bend or break. And as the title suggests, it's about adaptability. So this chapter explores how software must be designed to accommodate change and evolve over time. Something that's very common in our industry right now is change. Change is constantly happening. So how do you enable your system to withstand all these changes? So it introduces concepts like decoupling, modularity, and refactoring so that you're able to create flexible and maintainable systems. So in this chapter, they caution you against rigid designs that resist change because you need to advocate for forward-thinking development. Like if something comes up, for example, right now, everyone is thinking about how to incorporate AI into their applications. So if you had a rigid design, how would you be able to maneuver and adjust it such that you have AI advancements in the system? So if it was rigid, you'd not be able to do that. So yeah, adaptability in your systems. Then when we talk about concurrency, here he actually starts by explaining what concurrency is and what parallelism is, just so that you're on the same page. So concurrency is a critical skill, I would say. At some point in the book, he says it used to be exotic, but now it's a must. So it's a critical skill for modern programmers, and this chapter provides a detailed introduction into it. The authors discuss the challenges of designing and debugging concurrent systems, and they cover concepts such as race conditions, deadlocks, thread safety. These are things that we have heard, but they actually talk about them, yeah, and why they're important. So they explore the different approaches to concurrency, such as message passing, immutability, shared memory, and they emphasize the importance of simplicity and predictability in concurrent systems. So this is all about concurrency. It gets a bit technical, but I think I really liked this chapter. Then while you are coding, so you've talked about the tools that you have, yeah? You've talked about thinking about things like concurrency. So what should you be thinking about while you are coding? So in this chapter, they talk about the day-to-day practices of coding, which is what you do on a daily basis. Yeah. So they emphasize on clean, intentional designs and being able to write maintainable code. So they dive into techniques like orthogonality, that's the independence of modules, and the dry technique, the don't repeat yourself technique. So that's code duplication for dry, and code not splitting code across different layers. That's orthogonality. So they explore that along with the importance of like naming, comments, documentation, just to make sure there's clarity and you future-proofed your system. Yeah. Then you've talked about before coding. So what about before the project? Like before you actually get to the coding, what should you consider? So in this chapter, they are focusing on the preparation before starting a project. They stress about understanding the requirements, being able to manage expectations both on the user's end and on the developers end, and the stakeholders especially, and being able to plan for risks. So they discuss the value of being able to question your assumptions, prioritizing the user's needs, creating realistic schedules, not working on a project longer or shorter than it was intended. And they argue that good preparation is essential for delivering a successful outcome. And I can say from my experience that has proven to be true 10 out of 10 times. Then in pragmatic projects, this chapter has insights on how can you manage and navigate real-world software projects. Maybe you've mostly been working on projects by yourself, or you've been working on projects in smaller teams. So how do you now scale that out? So real-world software projects on a larger scale as well. So this topic talks about fostering teamwork, handling changing requirements, being able to deliver iterative results. And here the authors, they discuss the human aspect of programming, such as clear communication so that you're able to effectively communicate, building trust within a team so that you have that psychological safety, and ensuring collaborative success, because when the team wins, you're all winning. Then in postface, this was like a preface, postface. They have very interesting ways of naming things here. Here they reflect on the responsibility of software developers to have like a moral compass. Ask yourself, have you protected the user? Would you use this yourself? At the end of the day, you're human, yeah? And then it concludes with, it's your life, share it, celebrate it. Yeah, I think the last statement here, yeah, seem to have lost it, but yeah, it says it's your life, share it, celebrate it, build it, and have fun at the end of the day. So yeah, this is the Pragmatic Programmer in the 10 chapters, but I feel like that's not quite enough to give you a sense of what this book really talks about. So I'm going to go ahead and tell you about my key takeaways. So as Wambui, what stood out for me in this book? What did I take home at the end of the day? What did I feel quite resonated with me and challenged me to become a better programmer? First thing is, it's your life. In chapter 1, the first statement, like this book does not hold back. They tell you this book is about you. Yeah? The authors emphasize that it is your career. You need to own it. You have agency to invest in yourself. Yeah, you control your career, your growth, your work-life balance. It's all in your hands. Yeah, and you need to proactively steer your professional development to align with your personal goals and values. Because at the end of the day, who you are should also be reflected in the work that you do. So if you have personal goals and values, your career goals also need to be aligned with that. And I think we are privileged to be working in one of the best industries in the world. The tech industry integrates with every other industry that exists. So the opportunities are endless. If it's something that you want to work in healthcare, there's a way to incorporate tech in healthcare. If it's farming, there's a way to incorporate tech in farming. So you have different real world problems that can be solved with tech in a variety of industries. So you have an ability to learn new things in this world of programming, and that's your most important strategic asset. So you have to remember the value of your knowledge is also your value. Yeah. So if it declines, so does your value to the clients. So if you're not keeping up to date with what is changing, if you're not relying on the foundations that you have to be able to adapt to the new trends and technologies, then your value declines to your clients. So this book, it outlines guidelines on building your programmer portfolio. That's your knowledge base, yeah? So it likens it to a financial portfolio. Invest regularly, diversify your portfolio, review and rebalance every so often. So it gives you the same steps, but now with your knowledge portfolio, yeah? And they say learn quickly, but more importantly, unlearn very quickly. Be willing to let go of the mentality that I've always done this way. Yeah, because just because you've always done it that way doesn't mean that it applies in every scenario, because that mentality can change next week. That reality can change next week. We have all seen how AI has disrupted, generative AI specifically, how it has disrupted the industries. We've seen how Wall Street has been affected by the most recent release of DeepSeek. So you need to be able to figure out how do I adjust with the knowledge that I have, the knowledge portfolio that I have, how do I adjust? So what does this mean for individuals? You need to be able to set career goals and work backwards to identify the skills and experiences or projects that you need to achieve them. So you need to continuously invest in yourself by learning new technologies, read books, attend conferences and seminars, because they actually contribute to your growth. And then you also need to protect your mental health. You need to set boundaries around your work hours and prioritize hobbies and relationships, because programming is expressing creativity. And if you can't feed that creativity, it tends to run out. And that creativity comes from you experiencing things outside of work. So if you have hobbies, if you have relationships with people, you need to be able to maintain them so that when you come back to work, you're able to focus on your work. Burnout is a real thing in this industry, and it's something that takes a really long time to get over. So you need to be able to have these boundaries so that you don't get to that point. Yeah. So next up is programming is a craft. So it's a difficult job. There's no doubt about that. It's not, if it was easy, everyone would do it, yeah? But programming is intentional, yeah? We've been told we work small miracles every day. I keep saying that. Like once I read it, I was like, whew, nothing has ever described me better. So every day we try to transform vague user requirements into a language that computers can understand. Bruh, that doesn't sound surreal to you. As in, programming goes beyond just writing code. Yeah, it's about creating meaningful, high-quality software that is used by people. So we know of craftsmen and craftswomen, like I mentioned a few, carpenters, smiths, cobblers, and then they employ a good set of quality tools, and then they usually choose the best one at hand for the job. So in chapter 3, as I've mentioned as part of the summaries, they use the analogy of a woodworker who he lovingly chooses tools which are built to last, will perform specific jobs with little overlap with their other tools, and most importantly, they'll feel right in the woodworker's hands. So in the same way, you should care deeply about the practice of creating software. Your work should be a source of pride, and you should continually strive to improve what you're outputting. Another thing is you should aspire to be a polyglot. So a polyglot is someone who speaks multiple languages. But now we're talking about polyglot in the aspect of computers. So it's not enough to learn one language and stick with it with your entire career. What I usually say is be a jack of all trades, but a master of one. Just minimum of one. You need to be a master of one language, but then you need to also learn new languages. And what this does, it enables you to adapt to every situation by utilizing the best possible tools to solve the problem. So, for example, if you know there's a real world problem that you'd like to solve, and there's two of them. One of them requires Python, the other one requires, say, C#. So you'd be able to pick out which of this requires which based on your understanding of these languages. And the only way you'd have an understanding of these languages is if you practice learning different languages. So in the book, they challenge you to learn one new programming language every year. So I'm going to share that challenge with you. You can put it down somewhere if you choose to do it, all the best, and I do believe it will pay off. So try to learn one new programming language every year. The other thing is to ask questions and be curious. You have to ask yourself and others, why did you decide to do it this way? When you're asking others, you're learning their approach, you're seeing their perspective. When you're asking yourself, it's to affirm whether this is the best way to go about it or not. And is that the best way to solve it? So the result of that is you deepen your understanding, you broaden your perspective, and then you get a feeling of mastery and continuous improvement. And this is what squashes imposter syndrome. So a lot of us talk about imposter syndrome in the tech ecosystem. But when you know you have the basics and the knowledge and the experience on lock, that feeling tends to go away. So as an individual, you need to be able to adopt a craftsman mindset by treating every project as an opportunity to hone your skills. And then as part of a team, you need to be able to foster a culture of craftsmanship by organizing code reviews, hackathon, lunch and learn, and basically those brown bag sessions to share best practices. Then you need to be able to build an environment where quality is prioritized over speed, where team members feel encouraged to explore innovative ideas and be able to take calculated risks. The third takeaway is about accountability. So this is emphasized heavily in the book. They say pragmatic programmers are not afraid to admit ignorance or error. All because we are all humans, yeah? And human is to err. A lot of things can go wrong. Even when you do your best with testing, documentation, automation, everything, a lot of things can go wrong. We have come to see that. And the question is not a matter of if, but when. It is completely unavoidable. So the best you can do in such a situation is to acknowledge the problem. That's step one, yeah? Acknowledge the problem. Step two is to take responsibility for it. And step three is to try and offer options to fix it. So the automatic response of some people when faced with a problem, some complain, others immediately assign blame. They're like, no, that's not me. It was this. It's because Nani did this. That's the automatic response for different people. And you can blame your coworkers, you can blame the programming languages or the tools, but the fact of the matter remains that the problem is still there. So a good way to look at problems is to imagine it was not your code that didn't introduce, yeah? It was someone else's. First of all, it doesn't matter. Second of all, we are all working towards the same goal. So if the problem is there, whether it was brought in by you or somebody else, that's a non-factor, yeah? And when you help your teammates, they'll do the same thing for you later. It's a symbiotic relationship, and it builds a healthy relationship within the team to show that you can be trusted and you'll know that you can trust others. So the simple solution to this is to suggest options. Don't make excuses. When you're faced with a problem, before you approach someone to tell them about the problem, like why something can't be done or that it's not your fault, you should first stop and listen to yourself and ask, how does this excuse sound? Try position yourself in the other person's shoes, the person that you're going to tell, and ask, how would they take this? So take an example of you. Maybe your car is broken down and you've taken it to the mechanic and you've told them, I need it fixed in 2 weeks. And then you go back after 2 weeks, they start giving you lame excuses. How would you react? How would you view the company going forward? You'd probably never go back to that place, right? So take the same view for yourself. Before you do that to others, ask yourself, stop and listen to yourself and ask, am I giving excuses or am I suggesting solutions? So as an individual, you need to develop a proactive mindset. If you notice technical debt, don't wait for someone to fix it, address it immediately. Accept feedback gracefully and see it as an opportunity to improve. When someone is giving you feedback, especially positive criticism, it's to make you grow and to further you, and not necessarily to attack you as a person or to attack your code. I know some of us take our code as our babies, our creations, our most prized possessions. So don't take it defensively, but rather take it gracefully. And as a team, you need to avoid blame culture. When something goes wrong, focus on root cause analysis and focus on learning. How do we learn from what happened? So you can use retrospectives to do that. This is where you reflect on what went well and what can be improved. And then you should encourage everyone to be able to speak up when they see issues and empower them to act on solutions. So the Boy Scout rule is to leave a code base better than you found it. Yeah. So something the authors introduced to me in this book is broken windows. And I know it sounds weird. What do you mean broken windows? So broken windows is a phenomenon of, they describe it in a phenomenon of cities where some buildings are in perfect shape while others have gone really bad. So some researchers found out that there exists a trigger mechanism that can quickly turn a beautiful and clean building into an abandoned derelict. And what is that trigger? The trigger is a broken window. And they found that when there's one broken window, and if it's left unrepaired for a substantial amount of time, it makes the inhabitants of that area feel like there's a sense of abandonment, yeah? Like the powers don't care about the building. So another window gets broken, and then people start littering, and then graffiti is there, and then serious structural damage. So it spirals downhill. So this analogy, I feel, suits software very well. We've all seen code bases that were doing just fine, only to find out later that they're slowly descending into ruin. So a broken window can be anything from a shortcut that you took. It can be something that you did to make things easier for you at that moment, but were not necessarily the best decision. So like a broken design, architecture, a wrong decision, code smells. If you allow a broken window in your code base, you can be sure that there'll be more to come. So to prevent that, as an individual, you need to pay attention to small details in your work. So if you encounter messy code, take the time to clean it up instead of ignoring it. Again, prioritizing quality over speed. You also need to advocate for regular refactoring sessions or tech debt sprints. So tech debt sprints are sprints where you decide that for this sprint, we are going to be focusing on fixing the bugs, addressing any tech debt that you have identified. And for like an example is myself, the sprint that I'm in right now, I've been fixing a lot of the bugs in our code base. And while you may think that this has no positive outcome or contribution to your knowledge, it actually does, because it exposes you to the code base, maybe to parts that you have never touched or to things you've never explored, and you get opportunities for innovation as you're fixing those bugs. So it's actually something that works. So for teams, you need to maintain a code-based culture by you implement coding standards and automated quality checks. So like you have linting tools, or in your CI pipelines, you have checks for syntax. Like just make sure that you have checked the code quality standards and they are up to par with what you have agreed as a team. And then during sprint planning, you can allocate time to address broken windows. What are some of those broken windows that you have noticed that you would hope will be addressed in the future? Add them to the board, and then they will be allocated time. So debugging. I know this is something that can be triggering to some people, but debugging is not fun. Yeah, it's not always fun. Even in real life, running into problems is not fun, but it's part of the process. So debugging is a structured process that requires logical and calm mindset. And I say that because I usually liken it to people who play video games. I don't know if you've seen these videos of someone is playing a video game and then either their character gets crushed or killed and then they throw the pad on the screen and break it. Like, it's just frustration. Even me, sometimes when I'm writing code and I'm debugging, it can feel very frustrating. You feel like you want to take the laptop and smash it against something because you're so frustrated. But you need logic and a calm mindset to be able to get through debugging properly. You need to focus on finding root causes instead of quick fixes. That then helps you in the future. When you adopt the right mindset, you turn off all defensive mechanisms that protect your ego. That's hard, but it's possible because this will help you save time. You'll stop thinking that this can't happen, the code should be working well, it's impossible, but you're looking at the stack trace, like it's there. It's clearly a problem. So you need to put that aside first. Then you need to start with making the bug reproducible. Because if you can't do it, you'll never know if it is fixed. So you need to have the repro steps. Ideally, if possible, you can try and make the repro steps with a single command or a single action. That's ideally. Then you need to know that the root of the problem, it can. Keyword here being can. It can lie in the OS. It can lie in the compiler. It can also lie in like a third-party library. But that should not be your first thought. Your first thought should always be that you're assuming the bug exists in your code. Start from there. And then what that helps you with is that even if it does lie in a third-party library, in the OS, in the compiler, wherever it lies, you'd still be able to have to trace the problem from your code to that point. So that even as you're submitting the bug report to the maintenance, you'll say this is where it stemmed from. Then lastly, make sure that whatever was the problem, you will be able to know if it occurs again. So if your tests pass with the bug in the code, you can't trust them to catch that bug because they weren't able to catch that, whether it was an edge case or it's something that has no test written for it. So write a test, see it fail, then fix the bug, and then sleep well, knowing that you're covered and you will never encounter that bug again. So as an individual, some things that I've seen have worked is like rubber duck debugging. So in here at ADC, they printed for us some tiny purple ducks. I wish I had them. Some tiny purple ducks that we use for debugging. I actually thought I had one. Yeah. That you speak your code out loud to that duck to clarify your thought process, to be like, okay, so I'm approaching it from this angle. What could be the matter? And then use tools. You have to be good with the debugging tools, using the logging, the breakpoints, stack trace in your IDEs. Get familiar with the debugging process. And then document on those tricky debugging sessions that you have had, such that in future, if yourself or someone else is to encounter into a similar problem, you'd be able to give them the solution that worked for you. Then as a team, you need to be able to share this knowledge so that you collectively improve your skills. Then they have the concept of an engineering daybook. So have you ever found yourself, you're trying to remember, how did I solve this problem? Like, I know I solved it, but how did I solve it? You are wishing that at that point you had put it down somewhere. This one really resonated with me because I don't have the best memory. So I find myself writing a lot. Like, I have a lot of notebooks, a lot of both digital and physical notebooks. And it saves me a lot of time and energy when I note something somewhere. So the authors of this book, they recommend keeping an engineering daybook when working. So a daybook is like your own personal knowledge base, your own wiki. It's like a journal where you record what you do, the things that you learned, sketches of ideas that you're coming up with, notes from meetings, variables of values that you had when you were debugging, such things. Doesn't have to be quite formal. And this book has many benefits. First of all, it's more reliable than memory. You won't have to try and trace back in your head, what did I do at this point? It also acts as a rubber duck. So the act of you writing these things out helps you process, even if it's typing or writing, whichever the case. And it forces you to think about that problem before you put it down. And then it also acts as a database of documented memories. You can look at it and think about all the people you collaborated with, the projects you worked on, the problems you faced. And something that the authors didn't highlight, but I felt applies to me, is when you're trying to think about the impact that you have had. So you've been working on this project for how many years, and you sit down and reflect and say, wow, this is the amount of impact that the software that I have written has had on human lives or on businesses. So it's really quite a way to reflect, and it has a bunch of benefits. So the authors suggest to sticking to plain old pen and paper, but I think you can have both. Especially the digital version is a bit easier for me because it's searchable. Like, you can categorize your notes, and if you don't remember where you put something, you just search. So yeah, I think for individuals, you can create one to jot down the lessons that you learned, useful code snippets, and then you can review them periodically to identify patterns or recurring challenges. And this is where innovation comes in. You can also use it as a brainstorming tool to explore creative solutions to problems. So as a team, then this contributes to your documentation, your knowledge bases, your wikis, and you need to be able to treat your documentation process as a living system that evolves within the team with all the knowledge that you are collecting. So this is something I feel like we might all resonate: the fear of the blank page. It's intimidating, it's daunting. You're working on a new feature or a completely new project, like Hello World. Yeah, you have written Hello World, like it's come. The cursor is blinking, the screen is empty, and it's ready to be filled with code. And for some reason, it can be a bit intimidating or a whole lot intimidating, depending on how you're approaching it. And sometimes we might procrastinate and put off the initial commitment of starting. And the authors of this book think that the reason we feel this way is because we are afraid of making mistakes. We fear that maybe the architecture that we're implementing will not be flexible enough, or the code will not be readable by other developers, or you're stressing about introducing new bugs or problems, or you're thinking this task is beyond your skills. Like, how am I going to solve this problem? And you can't see your way through to the end. So the authors think they found a brain hack that seems to work in this situation. So they say, pretend that you're prototyping. Take a sticky note, write, I'm prototyping, and stick it somewhere. Yeah? Remember, prototypes get thrown away. So even if they succeed or they don't, they'll just be discarded. So it's a way to trick your brain into thinking, I'm gonna do it anyway, like, this is just trisex. If your mind knows this, you're likely to feel less anxious. And if anything goes wrong, you'll stash all of it away. No problem, move on. But what is usually happening at that point is sometimes you find that the code is just flying from your head into the editor. And it's because the initial stress is gone. You've started seeing the bigger picture, and you know how to proceed. So the suggestion to put that I'm prototyping on a sticky note and putting it somewhere you can see, I've tried it and sometimes it works. It's not foolproof, I'll be honest, and it helps with the hardest part, which is getting started, which I think was the goal. So as an individual, what you'd be able to do here is to set small achievable goals to build momentum. So instead of thinking, how do I complete a whole system, think about the MVP, the basic version, before you continue refining it. Then remember, reiteration will always lead to improvement, whether it's with feedback or with not. Just looking at it again will enable you to say, okay, I can do this better. You can add optimizations. And as a team, you need to celebrate milestones so that you're able to motivate the team and maintain momentum. At the end of the day, we are still humans. And you need to use collaborative brainstorm sessions to overcome creative blocks and generate ideas together. I really resonate with that idea because it works for my team. So the team that I work with, we have a session called backlog grooming. And backlog grooming is where we sit with the team. We say, these are some of the items that we have on our backlog, and we'd like to either start working on them in a coming sprint or in the next quarter. So the grooming part is where you break down the features into smaller tasks, and you're like, okay, this is how we should be able to approach this. And this helps such that when you're writing a design document or you are approaching the solution, you're writing different ways to solve that problem, you have already gotten over the creative block of starting. So as a team, you've put in different inputs, different perspectives of how to go about it. So when you actually get to starting, you incorporate all that, and it works perfectly. Then the other thing is to take small steps. So you were not born running. Yeah. You started walking by taking small and deliberate steps, trying not to fall. So you should always take small steps, then check for feedback and adjust before proceeding. And this feedback can be in different forms. It can be an MVP to show you that the client or unit tests to verify the correctness of your last code change. And this is important because it realigns you and saves you time before you start going towards further along the wrong direction. And then avoid steps that are too big and require you to predict the future. No one can predict the future. If you could, you'd be making millions. You would have known we should invest in crypto way back when it was a few coins, yeah? So no one can predict the future. Don't try to do it right now. You might want to think twice when you find yourself doing one of these things. Either you're estimating completion dates months in advance, or you're guessing users' future needs and preferences, or you're predicting future tech trends and tools. So since you can't predict the future, if you find yourself doing either of these, think twice. So regularly seek feedback on your work to ensure alignment with the expectations that are present, and then apply the Kaizen philosophy of continuous small improvements to your coding practices. Then for teams, something that I'd recommend is iterative development methodologies like Agile or Scrum, and ensure each sprint that you're working on has a usable increment of the product. So that then fosters a sense of an accomplishment and continuous progress. So you don't feel stagnated. You feel like at least at the end of each sprint, we have something that is produced. And when you use feedback loops to quickly adapt to the changing requirements, you also make sure that you're delivering value to your customers. Something that I really liked is they said that code is a garden. So I like to tell people I'm a farmer, even if it's a very, very small farm. I'm still a farmer. And I like to see living things. And I also like to see code as a living thing. It's not static. It is constantly evolving, and it needs regular maintenance. When you neglect code, it leads to decay. But if you consistently care for it, it'll thrive. So some people have compared code to building construction, which I don't think is right, because it implies that there's an architect that draws the buildings and it's approved and it's final. Then contractors dig the foundation, they build the structure, they apply final touches, and then at that point you can't change anything, just the interior. So I don't think that's what code is. I think software works differently. It's more like a garden where things are constantly changing. You plant different things according to the initial plan and environment. So like right now, it was drizzling 2 days ago. Right now, it's not. So you work with what you have at that point. So when you observe the typical weather conditions, you move to planting to other places if it works. And then if there's overgrowth, you split it. If there's weed, you pull them, you put fertilizer, you're constantly improving your garden. So the health of the garden needs constant monitoring and adjustment, similarly to code. The laws of physics, they don't constrain code as they do with buildings. And something that can help with this process is refactoring. Martin Fowler describes refactoring as a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. So you're altering what is happening in the insides internally, but externally what it's putting out to the user remains the same. Yeah. Then this technique is in line with the idea that code requires constant improvement and refinement. So make it a habit as a pragmatic programmer to improve code quality and reduce tech debt. And then as a team, you need to use tools to review the code, parts of the code base that need attention. Then I think something that might give us, all of us, a sense of relatability is being proud of your work. Pragmatic programmers should be proud to sign their work, just like the artisans of old age, like the painters, the Da Vinci's, the Monets. You should be able to say, I did that. You need to be proud of what you're putting out. And the idea of code ownership can be a double-edged sword. It can be either you are being territorial and are unwilling to, work on shared pieces of code. But that's not the side that we are looking at. We are looking at where there's a foundation of mutual respect among developers. And the golden rule is to make sure this works, yeah? So when you are accountable for a piece of code, you aspire to do a job you can be proud of. And it is the opposite of anonymity, which is it provides room for mistakes, sloppiness, bad code. Imagine if you didn't know who pushed a PR, or if you didn't know who made updates to a certain package. It would create an environment where no one feels any sense of responsibility, and that's not right. So aim to associate your signature with an indication of high quality. Yeah, when other developers see your code, they should expect it to be solid, to be well written, thoroughly tested, documented. But they say, that's Wambui's code. I know it's good. So build that reputation with the work that you're doing. So as a team, you need to encourage an atmosphere where everyone takes ownership and invests in the success of that product. Then conduct regular showcases or demos. Developers like to show off. So have demos where people can come and show off their code and be like, yeah, I did that. So that kind of impact shows the impact of the team's efforts. So I think we are at the end. And here I'm just going to conclude by saying, with great power comes great responsibility. You have been given the power to change human lives with software as a programmer. So the systems and devices that we build can shape the lives of millions. We've seen the impact technology has had on our lives, yeah? We've also seen the positive and the negative. So how often do you stop to think about, what's the impact of the work that I'm doing? The projects that I have worked on, what's the kind of reach that they have had? Whether it is to 50 users or to 100 million users, what has been the impact? And know that your imagination is everywhere. Our imagination has created social media, which has helped people make a living. We've seen TikTokers. It has helped amplify the voices of people to be heard across the world. We've seen the power of organizing protests. To the processor in your car, which stops your car from skidding. To the smartphone that you have in your pocket, which is basically a computer, which means you no longer have to remember some pesky details. So do your best to protect the users from any harm. As a programmer, first, do no harm. If you're involved in a project that requires you to do something that is against your beliefs or values, don't be afraid to say no. Ask yourself, would I enjoy to use this software as a user? Would I be comfortable with my sensitive data being shared out by this company or to this company? Do you know something that is important that users don't? So ask yourself these questions and put yourself in the perspective of a person who's using this software, because at some point you won't be contributing to it and it will take a life of its own. So you need to have responsibility from the get-go and realize that we are building the future for ourselves and our descendants. So your duty is to make sure you have a future that we would all want to inhabit and envision a future where we'd all have the courage to create it, build castles, be as extravagant as you want with your imagination, because the only thing that would stop you from building your dream software is yourself. And finally, it's your life. Share it, celebrate it, build it, and have fun. So we've come to the end of the book review. I really hope this was useful. Yeah, Excited to see if there are questions, discussions. Yeah.
Wow, wow, that's so awesome. Thanks so much. I think you've just set a new standard of how to do book reviews. I like that. It almost sounded like you had planned because you exactly took almost like 55 or 50 minutes, right, on the money. So that's really awesome.
Mm-hmm.
A few comments, I don't know if you can see them. Ben Osonga said, "This is just beautiful." Uh, Atate, it says it was an insightful session. Yeah.
Yeah.
So, but if you have any questions, maybe before we just close up, I know we are a bit just a few minutes over time, but yeah, here comes a question or a comment. Yeah, and Nziata Kenya says, yeah, it's a long one. I don't know if I could be able to let me try and post it here. Oh, yeah, okay, can read
Yeah.
it. Great review. Love the book. Focus on building an all-round program and uses great analogies on the topics. Yeah, that is a real. Actually, you got it right. Only
Mm-hmm.
read chapter one, but I love the that beyond the technical aspects, they cover communication, teamwork, adaptability, accountability. Yeah, great book. Thanks, Wambui and Anthony. So thanks so much.
You're welcome.
Really, folks really have loved this. That was a thorough and well-researched book review. I need to read the book now. That's
Please
Steve.
do. It's
Yeah.
actually such a really, really good book. You won't feel like you're reading something technical, but at the same time, you'll feel like, wow, this applies to me so much. So yeah,
Mm.
it really, really is a good book.
Yes, Joseph says very insightful. Yeah,
Great.
this is awesome. Yeah, here comes a question.
Mhm.
I'm curious to know an example of how we can display our portfolio. Do you have a structure?
So it's funny that Nanda and I were talking about this right before the session started. And
Yeah.
yeah, I think I don't have a portfolio, but I know of developers who do. So I would say there's really no structure. There's no one way to do a portfolio. So
Mm.
ask yourself, what is it that you would want people to see when they come to that site? What do they want to know about Steven? So there's no one way to go about it. I'd say introspect, see what it is you'd like to share, and then figure out how to achieve it. And remember, you don't have to do it yourself. So, like I was telling Nanda, I am a backend developer. So, I won't try and force myself to do the UI UX, to do the front end developer. I have friends who do that, and I can commission them, or I can tell them this can be, your side hustle, a project. Propose it to them and see how we can collaborate. So then that gives you an opportunity to continue building. So yeah, there's no one way to go about it, Stephen.
That's true. Good stuff. Joseph says he likes the code is like a garden.
It is.
Yeah. Yeah. So actually, thanks so much because I also actually haven't read actually the whole book. Yeah, I think I reached somewhere, but yeah, so like it was really insightful to hear like things like looking at code as a garden. So
Yeah.
code
It's
farming.
interesting. When I joined Microsoft, my onboarding buddy, that's one of the first things they told me. They told me, like, code is like a living thing. If you neglect it, it will die. And I have killed cacti. So I had to be I had to be quite attentive to that piece of advice, and it has really, really paid off. So yeah, think
Mm,
about it that way, and it will change your perspective.
nice. Ian says your breakdown of key concepts was spot on. I appreciate how you highlighted the practical tips that can immediately impact development work. Yeah.
Yeah, I really wanted to showcase how you can apply these concepts as an individual and as part of a team.
Mm, nice. Stephen comes back again says, what's your current or next read?
So technically, I don't have one in line. I was actually hoping to join the session for technical books on Monday, but could not
uh,
make because I know we'd have a book that we are reading. But for personal development, I'm reading The Mountain Is You by Brianna West, and actually Brianna West. And that book is loud. Please, just it shouts at you. Yeah, so I've been reading it very slowly because I need some time to decompress after I read a chapter. So yeah, you can check it out.
Nice. Yeah, good
Okay.
stuff.
So if there are any other questions, please don't hesitate to reach out to my LinkedIn. I'd be
Yes,
very
yes.
happy to respond and to connect. And thank you so much for tuning in. This was actually very, very fulfilling. Thank you for the question and the feedback.
Yes. Yeah, and thanks, all thanks to you actually, for honoring our invites. And you actually really done an excellent. I can't emphasize this. Like you actually set a new standard of how to do this. So really appreciate. Because when
No
you were
pressure.
doing this, we never knew exactly like how which approach to take. So,
Mm.
but you've really done an excellent job.
Thank you.
So
Thank you for
thanks so
having
much.
me.
Yeah, yeah. And by the way, so this is a call out to anyone out there. If you have a book you've been reading and you'd like to come over and just give a review, by the way, you're welcome. I know the bar is now very high, but don't worry, just come.
No pressure.
It doesn't have to be. Yeah, by the way, just a book summary. So basically, just summarize the book and what's your takeaway from it. We really appreciate. So
Yeah.
please reach out. Stephen, you look like there's a book you're reading. I have a feeling. So I look forward to hearing from you. So thanks so much, everyone, and have a good night. Hope to
Yeah.
see you in our next video.
Thank you.
All right, thanks.
Bye.